So the factor theorem gives us some information about what binomials are the factors of a given polynomial. We've dealt with the synthetic division. We've talked about what happens if the remainder is 0, and that's the condition we need for the factor theorem to hold. So what we're going to do is we're going to test each of these points, x minus 1, x plus 1, and so on, to see if each of those is a factor of this polynomial. So we do the synthetic division. In A, I would put a 1 outside my L. Inside, I would have 1, negative 3, negative 1, and 3. 1 comes down. Multiply, get 1. Add going down, get negative 2. Multiply, again negative 2. Add, get negative 3, multiply, get negative 3, and add one last time, getting 0. So I have a remainder of 0, which means that x minus 1 is indeed a factor of this polynomial. Now we could go through again and do the synthetic division 3 more times, but we can actually be a little bit more efficient about it than that. What we know is that this synthetic division becomes x squared minus 2x minus 3. And now to write this out completely mathematically correct, we would have that x cubed minus 3x squared minus x plus 3 equals what we divided by, that'd be x minus 1, times what our quotient was, x squared minus 2x minus 3. At this point, we can look at x squared minus 2x minus 3, and we can actually factor that down without using synthetic division because we have a quadratic. Two numbers that multiply to negative 3 and add to negative 2, that would be negative 3 and 1. And at this point, we can see all of the factors of this polynomial. So going back to the list in B was x plus 1. Yes, that is a factor. C is x plus 3. That doesn't appear, so no, it is not. And D, x minus 3, is a factor.